Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Here we are required to evaluate the orthographic projections of an oblique line which is having its ends in two different quadrants. So end A of the line happens to lie in quadrant number 2, while the end B of the line happens to lie in the quadrant number 4. So here let us read out the statement of the problem. So here we have got end A of the line AB. It is lying 30 millimeter above the horizontal plane and 20 millimeter behind the vertical plane. So therefore end A happens to lie in the second quadrant. So whenever a point happens to lie in the second quadrant, its front view projections as well as the top view projections, they will be drawn above the XY reference line. Then we have got end B of the line. It is existing below the horizontal plane and in front of the vertical plane. So here we have got the location of the point available to us in the fourth quadrant, but the distances of this particular point B below the horizontal plane or in front of the vertical plane has not been provided to us. So this we will be obtaining while we evaluate the inclinations of the line AB in the front view as well as in the top view projections over here. Further, we are provided with the information that the distance between the end projectors of the line measured parallel to the XY line happens to be 80 millimeter. That is, you have got the distance between the end projectors equal to 80 millimeter. Now, further the information provided to us is that is the front view and the top view. It is inclined at an angle of 45 degree and 30 degree with respect to the XY reference line. So with this information, we are required to evaluate the front view, top view and left hand side view orthographic projections of this particular line. So with the given information, we are going to start with the construction of the orthographic projections of the oblique line AB. So here we have got the XY reference line, X1, Y1 reference line and the transfer line which is located at an angle of 45 degree with respect to the XY reference line. So here since the 2 points A and B, they happen to lie in the different quadrants, that is quadrant 2 and the quadrant number 4. So we have to draw the transfer line which will be passing through the 2 quadrants over here, right? So now let us start with the construction of the orthographic projections corresponding to the end A of the line. So here we have been provided with the information that end A of the line, it lies 30 millimeter above the horizontal plane and 20 millimeter behind the vertical plane. So it means that end A lies in the second quadrant. So whenever any particular point lies in second quadrant, so its front view as well as the top view projections, they will be constructed above the XY reference line. So we know that the distance of the point A, it is 30 millimeter above the horizontal plane. So the point A dash will be lying 30 millimeter above the XY reference line. Similarly, the end A, it happens to lie 20 millimeter behind the vertical plane. So we are going to obtain the top view projection of the end A of the line at a distance of 20 millimeter above the XY reference line. Here we have obtained the front view as well as the top view projections of the end A of the line. Now having obtained the projections of the end A, now we also know that the distance between the end projectors corresponding to the points A and B, it happens to be 80 millimeter. So from this end projector line, right? So with respect to this end projector line, now we are going to measure a distance of 80 millimeter and draw a projector line which will be parallel to this particular vertical projector line corresponding to the end A. So this will be the end projector line corresponding to the end B over there. That is the projections corresponding to the point B, that is front view projection B dash and the top view projection B. So both of these projections, they are going to lie onto this particular vertical projector line. Now we are provided with the information that the front view and the top view projections, they are inclined at an angle of 45 degree and 30 degree respectively with respect to the XY reference line. Now usually if this point B, it was not lying in the fourth quadrant, so we would have drawn these angles in the positive direction, that is in the upward direction from A dash and from point A. But since in this case we have been provided with the information that the end B, it happens to lie below the horizontal plane and in front of the vertical plane. So it means that we are going to get the point B lying in the fourth quadrant. So since the point B lies in the fourth quadrant, so we are going to get the front view projections as well as the top view projections of the end B lying below the XY reference line. So here points B and B dash, so we don't know where they are going to lie right now, right? But one information we have obtained while we have evaluated that this point happens to lie in quadrant number 4, that is points B and B dash, they are going to lie below the XY reference line. So we cannot continue with the construction of these angles above the XY reference line over here, that is into the positive direction, that is in the upward direction. So what we have to do, we have to mark these angles, that is 45 degree angle with respect to the point A dash and 30 degree angle with respect to the point A over here in the downward direction. So we have to mark these angles in the downward direction. From point A dash, we know that the front view of this line AB, that is A dash B dash, will be inclined at an angle of 45 degree with respect to the XY reference line. So here from A dash, we are going to mark an angle of 45 degree, and this angle of inclination will mean that this projection line A dash B dash will be lying in the downward direction, and we are going to extend this line till this particular projection line, it meets the vertical projector which we had drawn corresponding to the end B over here. So this is the vertical projector line which we had obtained as a end projector line corresponding to the point B. So onto this particular line, both B dash and B points, they should be lying. So from point A dash, we have marked an angle 45 degree, and then in the downward direction, we have extended this line, and we will keep on extending this line till this inclined line, it meets the vertical end projector line corresponding to the point B over here. And this end projector line, it happens to lie at a distance of 80 millimeter from the end projector of the end A over here. So wherever we obtain the intersection of these two lines over here, so we are going to get the point B dash. So the A dash, B dash front view projection of this line has been obtained. Now similarly, we have also been provided with the information that the top view, it happens to be inclined with respect to the vertical plane at an angle of 30 degree. So from point A, so we know that AB line, so AB line will be the top projection, that is AB line will represent the top view projection of the line AB in the plan. Then from the point A, we are going to mark an angle of 30 degree, and we are going to extend this plan projection line and continue extending this plan projector line till this plan projector line will be intersecting with the vertical end projector line which we had constructed earlier, right? So this intersection of the vertical end projector line and the inclined top view projection line over here. So this intersection will give us the location of the point B. So this way, the top view projection AB corresponding to the line AB has been obtained. Now we have been able to obtain the front view apparent length projection of this line. We have been able to obtain the top view apparent length projection of this line. Now we are required to evaluate the left hand side view projection of this particular line. Now in order to obtain the left hand side view projection of this line, so we know that at whatever height point A dash was located, so the same height will be available with us even in the left hand side view projections over there. That is, the point A double dash will be located at the same height as that of the point A dash. So from A dash, what we have done? We have drawn a horizontal projection line such that onto this particular horizontal projection line, we should be able to locate the point A double dash over here in the profile plane. Now, how do we obtain A double dash point? So we also know that the distance of the point A from the vertical plane, it happens to be 20 millimeter behind the vertical plane. So this point A has been presented over here and it is located at a distance of 20 millimeter behind the vertical plane. So now from this point A, we are going to construct a horizontal projector line and extend this projector line till this construction line, it meets the transfer line into this particular position. So then here we have been able to obtain a point onto the transfer line corresponding to the plan projection of the point A. So point A has been extended in such a way that it is going to provide us with a location of another point onto the transfer line. And the moment we reach this transfer line, so from this point, we are going to draw a vertical projector in the upward direction. And once this vertical projector, which we have moved in the upward direction, it intersects with the horizontal projector, which we had drawn through the point A dash earlier. So this intersection will be giving us the location of the point A double dash. So what we have done by moving a horizontal projector from the point A up to the transfer line and then taking this vertical projector upward. So we have attained the transfer of the distance of the point A from the vertical plane in the top view to the same distance in the profile plane. Now we can check this point A double dash. It happens to lie 20 millimeter behind the vertical plane in the profile projection over here. Now we can check that point A double dash has been located in the profile plane in such a way that A double dash point, it is located at a height of 30 millimeter above the horizontal plane, and A double dash point lies at a distance of 20 millimeter behind the vertical plane. So this distance from the top view has been transferred to the same distance in the profile view over here, right? So this way, this is the purpose of using this transfer line over here. Next, we have to obtain the profile projection corresponding to the end B of the line. So once again, we know the distance of the point B dash from this particular XY reference line. That is, point B dash lies this much distance below the horizontal plane. So once we know this distance of the point B dash below the horizontal plane or below the XY reference line, so we know that even in the profile view, our B double dash point will be located at the same distance below the horizontal plane or below the XY reference line. So once we draw a horizontal locus line through the point B dash, so we will be obtaining the location of the point B double dash onto this particular horizontal construction line. Now we have to transfer the distance of the point B from the vertical plane into the profile plane orientation over here. So we know that this is the distance of the point B from the vertical plane. So please check this distance is x distance in front of the vertical plane, right? So point B has been located into the orthographic projections at a distance of distance x in front of the vertical plane. So once we know this is the location of the point B in the plan with respect to the vertical plane, now we are going to transfer this distance in front of the vertical plane by x distance into the profile view projection over here. So how this can be done? From the point B, we are going to draw a horizontal projector and extend it till this horizontal projector line, it intersects with the transfer line over here. So over here, we have been able to obtain a point corresponding to the plan projection point B over here. And from this point onto the transfer line, we are going to draw a vertical projector in the downward direction such that this vertical projector should be intersecting with the horizontal projector which we had drawn from the elevation projection point, that is B dash over here. So wherever these two projectors, they are going to intersect, we are going to get the location of the point B double dash over here. Now again we can check. This point B double dash, it is located at a distance of x millimeter in front of the vertical plane, right? And the distance of the point B double dash, it is same distance as the location of the point B dash from the horizontal plane. That is, the distance of the point B dash from the horizontal plane will be same as the distance of point B double dash from the horizontal plane. Both of these points, they lie below the horizontal plane over here by the same distance. So this way, A double dash point has been located, B double dash point has been located. So now we can join A double dash point with the B double dash point. So with this, we have been able to obtain the left hand side view projections of this particular oblique line when one point, that is the point A of the line, it was lying in the quadrant number 2nd, and the second end of the line, that is point B of the line, it happened to lie in quadrant number 4. So in the side view we can check point A double dash, it is lying in the second quadrant, while the point B, it is lying in the quadrant number 4. So this way the projections of the line, that is in the front view, in the top view and the left hand side view orthographic projections, they have been obtained over here. So this is all for today. So I hope that through this discussion you would have understood about how we can obtain the orthographic projections of the line when the two ends of the line, they happen to lie in the different quadrants over here. So we'll be continuing with further discussion regarding few more illustrative cases of projections of the lines in the coming lectures. So thank you very much. Thanks a lot.